Right, good afternoon everyone. I just wanted to start off with a recorded PowerPoint for you all. And so we're starting our new topic today, which is hydrocarbons. And we are going to be looking at in specifically today crude oil, how it's formed, how it's made up. We're going to look about how we can separate crude oil into its different parts, its different fractions, and then we're going to have an understanding of about how that process works and about how we can use those different fractions. So first thing for us to think about here is about the list of chemicals that we have, this list of compounds that we've got on our left hand side. Now there's something that you should be noticing about these chemicals here. So I'm just going to pause for a moment. You can pause the video, have a look at them, see what you notice. So the first thing that I would hope that you noticed is that they all contain the elements carbon and hydrogen, and so because they only contain carbon and hydrogen, we consider these elements these compounds hydrocarbons. What you might also notice is that there are 4 in the list, the top 4, which have the ending ANE. And we call those type of hydrocarbons, they're a family, they're a group together, and we call those the alkanes. Down at the bottom here, you can see that there are there's a different ending here, so they end in ENE, and so they belong to a different family, and they are called the alkenes. So all of these substances are hydrocarbons. So how did crude oil form? It was from marine plants and animals, in particular really tiny ones that we call plankton, which you'll know that some whales feed on, like baleen whales. And those organisms died and they end up forming a layer at the bottom of the sea. Over time we get more and more layers that end up being deposited, and these will include things like sand and silt, mud and other debris, and it buries those animals and plant remains lower and lower down, and we end up with more and more layers on top of them. So what we end up with is loads and loads of pressure being exerted on these plant and animal remains, along with the fact that they're now quite deep within the Earth's crust, and so there's also lots and lots of heat being applied to them as well. Now within those conditions, plus the absence of oxygen, we end up with our crude oil being formed, our fossil fuel being formed from these remains, because the breakdown happens in a particular way. And so now we have oil and natural gas deposits that we find deep below these layers, with lots of layers of rock on top. And when these are on land, we can drill oil wells down to them, or at sea we use oil drilling rigs in order to be able to obtain them. So in summary, we need to know a few things about crude oil. Crude oil is a finite resource, which means that it's limited. There is a limited amount of it found on the surface of this planet, and it takes millions of years to form, so it's not easily replaced, so we consider it non-renewable. It's made up of the remains of ancient biomass, so ancient living creatures, mainly plankton, which we can see in this picture over here, that end up being buried in mud. And what that means is that crude oil is a mixture of lots and lots and lots of different compounds, and lots of those are hydrocarbons. Not all of them, but most of them. Hydrocarbons themselves are molecules which are made up of carbon and hydrogen only. Right, so you need to pause the video here and make sure you write down these points. So just continuing on with our hydrocarbons, here's a way of visualizing what they are. So we can see here we've got 2 carbons with hydrogens around the outside. This would be ethane. And over here we've got 4 carbons with hydrogens bonded on all around the outside, and that would be butane. Most of the hydrocarbons that we find in crude oil we call alkanes, and we can use a technique called fractional distillation in order to be able to separate out these alkanes, these hydrocarbons, into different groups, different fractions, which is based on the length of the carbon chains which we find within them. So alkanes are the large family of hydrocarbons that we find within crude oil. They have the general formula CnH2n plus 2. What this means is that if we have 2 carbon atoms, then we'll have 2 times 2, which is 4, and then we'll add on to 2 onto that, which gives us a total of 6 hydrogen atoms. So we double the number of carbon atoms and add 2 to give us the number of hydrogen atoms. Now this table shows us the first 4 of the alkane molecules within the alkane group, and so we can see that there's methane, ethane, propane and butane, and here we can see the formulas, the chemical formulas for these substances. So here we've got 1 carbon atom, 1 times 2 plus 2 is of course 4, and we can see that pattern repeated as we move down the formulae for those different alkanes. Now structural formulae, remember, are where we use lines to represent the covalent bonds that we'd find between these carbon and hydrogens. And remember, a covalent bond is where we're talking about sharing a pair of electrons. So methane looks like this. We have 1 carbon in the middle, and we have a covalent bond between a carbon and a hydrogen, and that happens 4 times because carbon forms 4 bonds because it needs 4 electrons to fill its outer shell, whereas hydrogen only forms 1 bond because it only needs 1 electron to fill its outer shell. You drew this molecule back when you were looking at covalent bonding back in year 9. So ethane looks like this, propane looks like this, and butane looks like this. Now, this is a slide where you need to make some notes on this, please. The table you don't need to worry about. So, separating hydrocarbons, we can do this using a technique called fractional distillation. And over here we can see a diagram that represents our fractional distillation column. We're going to talk about this in a little bit more detail as we move on. So, these different bits that we're getting out, so we can see we've got residue for bitumen, fuel oil, jet fuel, petrol and gases here. Now each of those different groups we consider a fraction, and so all of the fraction that is petrol will be made up of molecules which all have a similar number of carbon atoms. Now these fractions will then be processed, and then we can either be used directly to produce fuels, like in the case of petrol or jet fuel, or they can be used as feedstock, so starting ingredients for the petrochemical industry, where we use these chemicals in order to make and produce lots of other chemicals, which we're going to come to. Right, you do need to make notes on this slide, please. You need to be able to know and explain the process of fractional distillation in some detail. So you're going to need to make detailed notes on this slide, and I would suggest you also do a diagram of the column that we... So we've already said that we use fractional distillation to separate crude oil into its different fractions. So the first thing that needs to happen is that crude oil is heated up so that it evaporates, so that it vaporizes and forms a gas or a vapor, and that vapor enters this fractionating column at the bottom. Now within the fractionating column we can see that there is a temperature gradient, and that's represented here on the diagram using colors. So it's the column is hottest at the bottom and it's coolest at the top. So as we go up the column, the temperature will decrease. So what happens is that we have these gases, this hot crude oil, enter the column at the bottom, and the gases will move up the column. Now as they move up the column, they will condense, so they'll form liquids, and they will become liquids at different heights depending on their boiling points. And what will happen is that when they'll become liquids is that we'll be able to take that specific fraction off at these different heights. So these different fractions have different boiling points. Now, those boiling points are determined by the length of the chains that we find within the fraction, within the crude oil mixture. So longer chains, larger molecules have higher boiling points, and we'll explain that next lesson. And so we find that they will collect near the bottom of the column, whereas fractions that have smaller molecules will have lower boiling points, and so they will come out as gases at the top, or they will condense at much cooler temperatures in order to form gases. Whereas lower down the column they'll remain as gases, and so they won't condense, so they just keep on moving up. This is a really common long answer question, so you need to be able to recall most of the bullet points on this page, and you need to be able to explain this in a lot of detail. It's also a really common question that you get asked loads and loads of times. So we can carry out a model of fractional distillation in a laboratory using this equipment. So down at the bottom here we would have some mineral oil, and that would be soaked in crude oil, and what we'll do is we'll heat this up, say, to 100 degrees C, and we will collect the vapor that comes off and use this cooling water in order to condense the vapor into a liquid, and we can collect the fraction that comes off at 100 degrees C. Then we can increase temperature to 150 degrees C, and then to 200 degrees C, and we'll keep on carrying out the same thing, and we can collect a series of different fractions so that we're able to separate out this mixture of hydrocarbons that we find within crude oil. Now, you need to know about the uses of the different fractions, so this is a slide that you're going to need to make notes on as well. So one of the things that we can, one of the big uses for the fractions that we get from crude oil is as a fuel. So you'll recognise petrol and diesel, which we use for normal kind of transport, but then we also get kerosene out, which is another name for jet fuel, and we will also get a heavy fuel oil. So this comes right at the bottom of the column. This is really long chain molecules, really big molecules, and so they will condense at they've got really high boiling points, and so they come out the bottom of the column, and we use that in order to run ships. But we can also see, and we'll see this in the next slide, we can use this as a lubricating oil, and we can also use it as the tar that we put on roads in order to protect it. So you need to make notes on this slide, please. The other one fraction that we get out is LPG, liquid petroleum gases, and you'll be more familiar with this as propane or butane, the kind of things that you use for your barbecue, or the gas that we get in for Bunsen burners, or the gas that will be used in your gas central heating at home, or the gas that you use in your cookers. Now, we also talked about them being used as a feedstock for the petrochemical industry. So you can see here that lots of materials that we use in our everyday life are actually produced from petrochemicals. And so actually one of the biggest uses and the most important uses of crude oil is in this. So we can use it to produce solvents, like those that we use to make paints and glues, lubricants we've already mentioned, but used in engines and other types of machinery, polymers to produce plastics like those that we find all around our home, like polythene, polyvinyl chloride, but also those that we find in clothing, so polyester. Detergents, so this is a really interesting one. Lots of the washing detergents, so your washing up liquid that you use at home, your washing powder that you use at home will actually be made from petrochemicals, and also those that we use to wash our bodies, so shower gel and other washing products utilize petrochemicals in order to do it. And what we can see over here is actually a whole range of really interesting things. So you can see we get aspirin, Tupperware, and wax paper, candles, petroleum jelly, all lots of different things that we get from crude oil that our modern life is absolutely based on. You need to make notes on this slide, please. So all of this comes down to carbon, and so it's about the fact that carbon is a really amazing kind of element. One of the reasons being, as we can see in this diagram, that it's able to form 4 bonds represented by these 4 hands. And what this means is that it can join together in lots of different ways, and it makes lots of different compounds as a result. So it will form families of similar compounds, and that can be joined together to give us really long chains, or they can also be joined together to form rings. And so we get lots of different naturally occurring and man-made or synthetic compounds which contain carbon, which are really important to us. You'll need to make notes on this slide, please. So there are a number of questions here for you to consider first of all. So pause the video at this point, answer these questions, and then we'll go through the answers. So what is crude oil? Crude oil is a finite resource found in rocks formed from ancient biomass, which is made up of a mixture of compounds or hydrocarbons. Oil is so important to society because it's used as fuels and as a feedstock for the petrochemical industry. We can separate crude oil using distillation because it's a mixture of different molecules and they all have different boiling points, so we can use that property to separate them. And the general formula for an alkane is CnH2n plus 2. Considering those extension questions then, so alkanes which have 6 to 10 carbon atoms, so we would have C6H14, C7H16, C8H18, so remember we're doubling the number of carbon atoms and adding 2, C9H20 and C10H22, and the displayed formula of octane would look like this. Right, final thing for you to think about. Which of the following are hydrocarbons, therefore which are not hydrocarbons? Pause the video, have a think. Right, there should be 3 in there that you should identify as not being hydrocarbons because they don't contain just carbon and hydrogen, they also contain oxygen and one of them contains sulfur as well. So they are the 3 that are not hydrocarbons, which leaves us with this list here. Now, attached to the Show My Homework, there's also going to be a worksheet for you to have a go at, and there's also going to be the answers for that worksheet. Right, thanks a lot. Thanks for listening. Have a good day, and I will catch up with you during your next lesson. Send any questions if I show my homework, and look after yourselves.